We have already considered the climate change impacts on economics, and I have had some of this information put into some courses in other places, but in this context of introduction to climate science, climate change, climate modeling, I thought I would include this again, so hopefully it's not a duplication. Okay, so this is a report just came out last year from the Swiss Re Institute, the economics of climate change, no action, not an option. So at this point the argument is that climate change action is a must. So it looks at the impacts of climate change, various warming scenarios on GDPs of various regions and countries, and the benefits of climate action on the same regions and countries, including the transition risks on various sectors. So let's just run through these for just an introduction. Temperature increases are here from the pre-industrial times to mid-century and relate to increasing emissions and or increasing climate sensitivity, which is reaction of temperatures to emissions from left to right. So we have already discussed climate sensitivity elsewhere, how much warming happens with respect to given amount of increase in greenhouse gases, especially CO2, right? Temperature rise scenarios by mid-century. So Paris target is well below 2 degrees centigrade by 2100 with a 66% probability, and 2 degrees C increase, 2.6 degrees C increase, and 3.2 degrees C increase correspond to the various representative concentration pathways that we had discussed. So corresponding to those scenarios, what would be the impact by mid-century? So this is sticking to Paris Agreement and the likely range of global temperature gains if we don't take action to meet the Paris Agreement targets, and this is the severe case considered here by one of the scenarios. So simulating for economic loss impacts from rising temperatures in percentage of GDP relative to a world without climate change. So in that case, the counterfactual world is where human beings would have had no impact. So the change in temperature with respect to pre-industrial would be 0 degrees C in terms of anthropogenic warming. Of course, natural climate variability would have done something. So as a whole, the world in the most benign case would lose 4.2% of its GDP, and then this increases as you allow for more warming to occur without taking climate action to contain the warming. OECD's, the Organization of Economically Cooperating and Developing Countries, is somewhat better off than the world, and then gets worse with increasing warming. Of course, North America is safe. Well, I don't know if anybody is safe, but 3.1% drop in GDP by 2050. South America obviously a bit worse. Europe is better than North America here. Somehow when you include all the indices, it turns out to be better. We'll look at the top 5 and bottom 5 in a minute. Middle East and Africa, Asia is quite worse off, 5.5% loss in GDP by 2050, even if we stick to the Paris target. ASEAN would be at 4.2% loss, and advanced Asia would be at 3.3% loss, and Oceania as a whole would be 4.3%. So there is corresponding increases as warming increases. But if we look at the GDP gain, so here we simulate for severe economic impacts / uncertainties from climate change. The figures shown represent the difference of the 2.6 degree scenario and the Paris scenario as percentage GDP in a world without climate change. So if you contained it to Paris Agreement and below 2 degrees C and allowed it to go to 2.6 degrees C, which is under I think RCP 4.5, then what would be the GDP loss relative to the case of no climate change? So ASEAN would gain 25% if the warming is kept to below 2 degrees C. Middle East and Africa would gain almost 16%, Asia 15%, world as a whole would gain 10% in GDP. South America, advanced Asia, Europe, obviously countries who are not losing much also do not gain much when you allow 2.6 degrees C warming to be contained to 2 degrees C warming. OECD is similar to Europe, and North America is even less than that. So this is a model with various assumptions, and we will see the transition risks in a minute. But keep in mind that this is basically saying you have to look at cost and benefit ratios of investing in containing global warming to less than 2 degrees C with respect to pre-industrial by 2100 with a 66% probability versus what GDP we would have had if human beings had no climate impact at all. Okay, so looking at the physical risks in terms of GDP impact, extreme dry and wet weather risks, and current adaptive capability rankings and climate economic index. Extreme weather risk here is proxied by Swiss Re Institute's climate risk scores that reflect individual country potential exposures to extreme dry and wet weather conditions or events on account of changes to the climate. Exposure itself obviously is depends on infrastructure and other things that make you vulnerable for a particular climate hazard. Adaptive capacity rankings are based on the Climate Change Adaptive Capacity Index from Verisk Maplecroft. Our sample analysis covers 48 countries, accounting for 90% of the GDP in 2019. Okay, so there are 48 countries, and we are looking at the top 5 countries and bottom 5 countries based on all the indices, physical risk changes, current adaptive capability rankings, and climate economic index. That's why you don't see China here, for example. It's somewhere in the middle. Finland is ranked 1, Switzerland, Austria, Portugal, and Canada. So the GDP impacts are shown here in terms of the physical risk rankings. The dry and wet weather risks they face. Finland, for example, has a low risk for dry weather risks like droughts, whereas it has much higher risk for wet weather events. Similar for Switzerland, similar for Austria. Portugal has much higher dry weather risk, it's Mediterranean climate, and also wet weather risk, it's subject to North Atlantic oscillation impacts and so on and so forth. Canada has again the 5th rank in terms of GDP impact, has both dry and wet weather risks of similar amounts because of its extent and latitudinal position as well. And here is the adaptive capability rankings. Switzerland is better than Finland, Austria, then come Portugal and Canada. Climate economics index again increases here from 11.3 to 16. In the bottom 5 are Thailand, India, Philippines, Malaysia, and Indonesia. These countries face a lot of dry extreme weather risks, and you can see Malaysia has both, but still wet weather risk is 50% of the dry weather risk, and Philippines has mostly dry weather risk. It's already aware of its typhoon risks and so on, so we have to worry about dry extreme weather risks there. India has a significant dry extreme weather risk with some wet extreme weather risk as well, and those are the adaptive capability rankings and the climate economics index. Okay, you can read up the details in the Swiss Re report. I'm not going to go into the details. Basically, I want to give you a sense of the calculations that have been done in translating the RCPs into climate projections and warming, and transitioning those into extreme events and so on, and then transitioning those to climate impacts. There are integrated assessment models involved, as we have talked about, and we'll see how Swiss Re does these impacts in a minute with a table. Obviously, the transition risks are involved here as well. For example, imposing a global carbon tax of US $100 per metric ton, let's say as a global decision on climate mitigation, would create an impact on the energy, materials, utilities sectors most. By region, revenue weighted earnings would fall by a fifth in Asia Pacific and by 15% in the Americas and Europe. So we are looking at Americas, APAC, and Europe here. And we are looking at communication services, discretionary consumer sector, staples, impacts on staples, consumer staples, energy, financials, healthcare, industrial, IT, materials, real estate, and utilities. You can see that energy, materials, and utilities are impacted much more in each of these regions, and you can see the various percentages here. Energy for APAC would be as high as 80%, whereas for materials it would be higher than 70%. In utilities it's almost 70%. So you can see that even Europe faces significant transition risks when you impose a global carbon tax. So in other words, when climate action is taken through a carbon tax, the transition risks in these various sectors would be very high for some of the regions of the world. So Swiss Re's approach to assessing the economic impact of physical and transition risks associated with climate change includes drivers in physical risk and transition risk. Transition risk corresponds to technology advancement, regulation change, and consumer preference, resulting in carbon tax scenario analysis. Here the driving forces are chronic gradual increase in temperature, for example sea level rise, and acute events like extreme weather, floods, heat waves, wildfires, which lead to impact modeling in terms of GDP loss impact through scenario stress testing and climate risk score, and then including adaptive capacity, which produces an aggregate climate index that we just looked at. Together that gives us the economic and financial conditions that we are addressing here. The overview of climate change impacts on world real GDP by mid-century, of course, gets worse with the worse RCPs, or representative concentration pathways. The middle of the way RCP 4.5 is here, and the business as usual and the worst case scenario of RCP 8.5 is here. The Paris Agreement is the RCP 2.6, remembering again that 2.6 is in watts per meter squared radiative forcing resulting from those emission scenarios. So here we are, negative refers to no simulated parameter uncertainty, and times 5 and times 10 represent increasing severity of potential outcomes from known unknowns and unknown unknowns. So various additional sensitivities are done in terms of simulated parameter uncertainties for real GDP impact versus no climate change. So the counterfactual word of no anthropogenic climate change versus these scenarios. You can see that no simulated parameter uncertainty gives a small change in real GDP, which increases with known and unknown unknowns of 5 times and 10 times. So you can see the range there. So the range still remains within 5%, whereas with RCP 2.6, if we exceed the 2 degrees C, if we remain within 2 degrees C as per Paris Agreement, then the unknowns can drive the loss to more than 10% here. And we are currently on a trajectory of RCP 4.5, so there is still a window of opportunity to dial back and get back to RCP 2.6. So the warming here would be 2.6 and 3.2 as we saw before by 2050. So this would be serious issue in terms of world GDP loss of let's say order 2% here, order 8% here, and almost 15% here. And of course, with 3.2 degrees C warming under RCP 8.5, you would have almost 18% world GDP loss for 10 times the potential outcomes from unknown unknowns. Okay, so it's a kind of gives you a sense of how economic impacts are computed and how we can look at cost benefit ratios of investing in climate mitigation, meeting Paris Agreement targets of 1.5 degrees C, 2.5 degrees C global warming targets by 2100 with 66% probability. These do not say exactly how we will get there, so that detail is still to be addressed. For example, in terms of the technology that is available for carbon capture and sequestration or negative emission technologies, which would be very critical parts of remaining within 2 degrees C or especially 1.5 degrees C, because the emission reductions are not going to do that by themselves. So we would need negative emission technologies and scalable direct air capture and other carbon capture and sequestration methods. So this doesn't address that. This just assumes that somehow we are able to meet those targets and then look at what it means in terms of physical risks and transition risks and then calculate the impacts. Okay, just keep that in mind. If you want, again, there are lots of good reports and articles that you can read up. Okay, let me leave this here.